So the last time we stopped at equation 7, right? Let me just write that out. All right, so this is equation 7, the last thing we did. Okay, so of course we're using our notes directly this time in order to catch up in terms of speed and things like that. So this is equation 7 here in our notes. Okay, now where V is some scalar potential function, the negative sign is arbitrarily chosen for later simplification. So simplification of results. Now, for this whole thing, we've explained how we got here in the last video. And of course, the negative sign, don't worry about it for now. Okay? Just know that it was added, or we have it here, or it's necessary to have it here for further simplification. So this is what we have right now. Now, to move to the next thing, this is what is said in our notes. That if we find A and V, okay, remember we already have an equation 7 bearing A and V. Look at it, A and V. Vector potential, then scalar potential. So you see the topic potential functions. Okay, so these are the two guys. So now if we find A and V, we can find B and E. Meaning if we find the if we find the vector field, we find the scalar field, we can then find the electric and what the magnetic field. Of course, this is magnetic flux density, but it has to do with magnetic field because this is equal to what? Equal to permeability multiplied by magnetic field intensity. So it's they're related. All right. Okay, so the next set of equations we have in our notes are equation 8a and 8b, which are just from already existing equation. Equation 4 was written again. Equation 4 was written again to give us this. This is taken as equation 8a. So it's not even something you look at it. Equation 4. But we can see that equation 4. Okay, the same as what? Equation 8a. Alright, then equation 8b, look at it, equation 8b was just what? This same equation, but these other guys were moved to this other side. Okay, of course, we know for simplicity, we just say it is moved and the sign changed to negative. For simplicity, we just say that, but we know what's happening mathematically. Okay, subtract this from both sides. So what we now have is what? Minus j omega A and then minus the gradient of the scalar field to give us equation 8b. Okay, so this is where we are now. Now, generally, have it in mind that generally, we first of all find this one, find the vector potential, which is magnetic vector potential, and after doing that, then we find what? The scalar potential, and then use it to find the what? The electric field. Okay, and of course from there you can go for the magnetic field and things like that. So we know how we got here from the previous video. So all we did here is just to make E subject of the formula, so that we'll do what? We'll find this and find this, and then we put it into equation 8a. Okay, this is not a question to solve. This is not the question. Okay, we are to solve. It's just we are just deriving equations for now. Okay, and in our notes we've gotten to, I think, equation 50. Okay, we've gotten to, in our notes we've gotten to equation 51. Okay, so that's why we have to speed up now. So equation 8b, this we are right now in our notes. I will follow. Now there's a reason why we had to rewrite this equation. Okay, because we want to use it for something. Look at equation 1. Okay, we've got something for the electric field, right? So now look at equation 1. Equation 1b. You can see this is what the coil of the magnetic field intensity equals everything you have here. Now, instead of having the magnetic field intensity here, you can have the magnetic flux density, which is B. instead. Okay, but this is equal to what? Equal to this. We've said that a lot of times. So by doing this, look at this equation now. Okay, let me. So by doing this, here you have this h, you put what? You put b. Okay, but in order to do that, you do what? You say this, you multiply equation 1b through by what? By mu naught. Because for, let me just write the equation. Let me just write the whole thing here. Okay, so this is the equation 1b we have here. Okay, so since we want to do this, want to have the magnetic field here, you can, or you are to replace, or you are to add this mu naught to this part here. But this is an equality sign. Whatever you do to this side of the equality sign, you should also do that to this other side. So meaning we are going to have mu naught here also. So it will now be what? J omega mu naught. Here also mu naught. Okay, so then we can now do this, saying this is equal to this j omega mu naught epsilon naught electric field plus mu naught js. Okay, and that is what you have here as your what? Equation 9. Okay, yes, that's what you have as equation 9. So let me dot. I don't have space here again. I don't have space here, so that's how equation 9. Okay. Now, for equation, the next equation, substituting 8a, we obtain what? This. Look at 8a. Okay, 8a. So, okay, so look at 8a. 8a says this guy is equal to everything here. Is that not so? Meaning, this b, which we have here, look at it. Look at it. The same b, right? Meaning you have to remove this b and plug in this. Plug in that. This will now serve as what? Equation 10. Are you saying it? That serves as equation 10. So here become 10. Alright, so the difference between equation 10 and equation 9 is just this. For equation 9, we have what? B here. But look at our notes. This is what they have. This is exactly the same as what? As this. Okay, and from equation 8a, we saw that it's also equal to what? This. So placing this one here gives us equation 10. Good. Now, in case you are wondering, so where are we heading to with all these equations? We are trying to arrive at a particular equation where it will be easy to solve for A and V. Okay, A and V. Right? And when we solve for this, they will now solve for the electric and then the magnetic field. That's what we are trying to arrive at. A simple equation. Right? And then, of course, these equations has been simplified years ago. How they got to that simplified equation, that's how we are just following, going through the process which they have simplified already. That's why almost everything looks predefined or looks defined, like a defined path to follow in achieving those equations. Okay, so let's go. Let's continue. So we stopped at equation 10, right? Now, if you look at equation 10, it already looks like what? That equation containing the Laplacian. Let me make this clear. We have this here, this here. There is an equation like this. Here we have the coil of a vector field is equal to what? the gradient of the divergence of the same field subtracted by the Laplacian of the field. This is an equation which has already been derived years ago. So we just rewrite the equation, write the same equation and call it equation 11. Alright. Now comparing equation 11 to equation 10, you can see that what we have here, what we have outside here is exactly the same to what we have here. Are we getting it? Meaning we can say all this is equal to what? All this. Do we get what's going on here? All this is equal to all this because this and this are the same. This is equal to this is the same. Therefore, this is equal to this. That will give us equation 12. So let's quickly do that. So we can say that the gradient of the divergence equal to minus the Laplacian is equal to everything we have here. So it's equal to j omega mu naught epsilon naught electric field plus mu naught js. Now, if you look at our notes, you will see that this is supposed to land at equation 12. However, you can see that our note is a bit different from what we have here. So all they did is actually to simplify this, and they will arrive at this point. So let's do that simplification and arrive at. Okay. So let's do that simplification of this and arrive at this point quickly. Now, I've already done that the back of my notes, so let me just quickly show us, or let's just do it together. So looking at this particular one, you can see that it has already been derived here from equation 8b. So that one is what? Minus j omega, minus j omega a minus this. Look at it. Okay, that's why in our notes you have this being said, that substituting what? 11 and 8 into 10. This is 11. This is 8b, right? 8b, which is this, into 10. Where is 10? Look at 10. So that's why we have 10, this one, this way. All right. And this is the 11. And this is the 8b. Okay. So what we're going to do now is to have this here. Here you have this, you replace with this. So let's do that quickly. I'll just rewrite. All right. I think I still need extra space. Let me just put it down here for this one. Good. So now it's just time to do what? To simplify. And once we simplify this in further, we are going to land at the equation 12 we have in our notes. Let's do that quickly. So first things first, open these brackets. So let me write this guy. So this part remains the same for now. By the way, this is the Laplacian, the one that has this square. Nabla square A is in. This is the Laplacian. Don't worry about the name Laplacian, okay? But that's what it's called. So when we open this bracket, this multiply this. J multiply J is what? Minus 1. Minus 1 multiplied by a minus makes here positive. So then this multiply this, you get what? Omega square. So you see there's no minus sign here again. No more minus sign. Because this multiply this is minus 1. And minus 1 multiply this give you positive. So this times is omega square. And then what again? Of course, everything here multiply everything here. Okay. So this will give us omega square. This whole thing multiply. There are two terms here, right? This is a minus sign here. So this multiplies this. That's giving us this omega square mu naught epsilon naught and then what? A. Right? There's a bar here. Okay. Then that's for the first term. Then the second term, this multiplies this. Note we have a minus sign here. And then what? J omega mu naught epsilon naught. And then what? This guy will also be there. Hope that's clear. And then we have some plus this guy here. Good. So what do we do now? Simplify. Alright, so since we have that, what we are going to do now is this. Let's move this one, okay? We want the Laplacian to be at this other side. However, it has a minus sign, so we'll just move it to this other side. Whichever way you want to do it, but I just want to move this one this way so that this will become a positive sign to avoid all those divide by minus one and things like that. So I'll move this one this way, okay? And then all this one has this sign, right? The gradient of v is here. We also have a gradient here, so I'll move all these ones with gradients this other way, and this one will be Laplacian and move it this way. Okay, so we'll now have what? This. Then the ones with the gradient, when it comes this way, become positive. So our Laplacian is now this way. That will give us then this one. Okay, so we can see all positive signs there. Now, looking at this expression we have here, you see that gradient is common. Okay, so gradient of this, gradient of this. So you can actually do what? Factor out gradients. Alright. So when you factor out the gradient, you have gradient and then you got the bracket. This will be what? This will be here plus j omega u naught epsilon naught v. Okay, this gradient and this gradient is now outside. This one is here plus this one and the v is here. Good. Equal to all the same thing. We need to write them again. Everything here, the same thing we have here. Okay. Now, let's look at what we have in our notes. So looking at what we have in our notes, we can see that the Laplacian and this other one are separate together, which is this. And then we have minus this, and this is our expression. We have it here with the v. Okay, so we can do that. So let's just move this one. This will just transfer them. Everything here switch it this way. So that will give us what? Let's write this out. So all these guys will be what? Here. The Laplacian plus, oh, I should have added all this y. That, and then what? This equal to, note, we could have done this. Let me even do it first. Add this one first. Js equal to what? All this. Don't think I have enough space, but let's just manage. Okay, so all that happened there, I just change the side. All this one, bring it this way. This one, bring it this way. That's all that's happened here. Then to match with what we have in our notes, you take this one this other way. So you now have what? This equals. Okay, I think they wrote this one first in our notes, but it doesn't really mean which one you write first. Okay, so then plus is plus sign. All right, so that gives us the exact equation 12, which we have. Equation 12, which we have in our notes. Equation 12. Okay, so you can see it's all right. They changed, they switched this thing. It doesn't really mean this one doesn't mean in epsilon naught, mu naught, whichever one comes first doesn't really mean much. Okay, if you switch it by mistake, I think it's kind of a sign that you did this on your own. You didn't you didn't look at anywhere. All right, so that doesn't really mean much. Then you for leave an yes. And what again? All right, that's what we have there. Okay, and then this good, and then this other side too. Good. All right, so that's equation 12. So we'll stop here for this in this video, and we'll continue from this part next time.